All right, so this learning objective is all about differentiating inverse trig functions. And again, I put them over here. Again, this one is mainly just making sure that you have these things memorized. So again, they're just kind of flashcard problems. Arc sine of x on one side, 1 over the square root of 1 minus x squared on the other side. All right, just do these flashcards so you have these 6 things memorized. All right, so at this point, you should have like 30 flashcards for all the different derivatives. You have these inverse trig functions. We have our original trig functions. You have exponentials, logs, power rule, all that kind of stuff. All right, so just kind of have these flashcards, go through them to make sure you don't forget what an derivative is for one you should know, because then you can't do these other problems that use that information plus a little bit extra. All right, but this problem, you have your function f of x equals arc sine of x, and this is really similar to, I think it was 2.10, where we're taking the derivatives of the original trig functions, but this is just the notation for finding the derivative and then doing it at 1/2. So this says we're just going to take the derivative of arc sine of x, which is 1 over the square root of 1 minus x squared, and we're going to plug in 1/2. All right, so now we need to simplify this and hopefully get one of these answers. All right, 1 over the square root of 3 over 4, and then that is 1 over the square root of 3 over 2, and this 2 is going to go to the top and make this 2 over the square root of 3. So C is the right answer. As you recognize in that it's the derivative notation, you do that, plug in 1/2, and it's just a bunch of simplifying after that. One thing I didn't mention either, these things are kind of interchangeable. The arc and the inverse notation, they're just interchangeable. They mean the same thing. So this is the same as sine inverse. This is the same as arctan. So you'll see both of these things. So d dx of secant inverse is the same as arc secant. So this is just trying to match these ones up. Again, there's multiple ways to write these, especially with these kind of weird square roots and stuff. So we're just kind of see which one of these looks the most like what's on the right. We have something and something squared minus 1. All right, so none of those really look like what we have. But if we just kind of match up what we think we know for sure, we definitely know this one's positive and not negative. And then we're kind of just looking at C and D, and C is positive and D is not. So it's just another way of writing this one. All right, the one that I have written is more useful in general because there's kind of less things. You have this fraction in here and an extra exponent. So this is the more simple version. All right, so you're just kind of seeing what you have and comparing it and making sure you kind of make sure things make sense. All right, so for 27, we're doing cosecant inverse. All right, so we're doing this. Where's cosecant? Oh, at the bottom here. All right, so it's really similar to the one we just did. It's going to be -1 over the absolute value of x, but instead of having an x on the inside, we have an e to the x. That's going to be the absolute value of e to the x. Then the square root of e to the x squared is e to the 2x minus 1. We have to multiply that by the derivative of the inside, which is e to the x. So again, none of these match exactly. The one thing we definitely know is that it's not a or b, because there's no trig functions in our final answer. All right, so looking at, does it match more to the answer that we got using our expression? Does it match more to the first one or the second one? But the first one, there's no negative answer, so it has to be D. And this is really kind of weird simplifying thing that Calc does, or the AP program does, of making this a fraction. All right, it's not really something that I would do in general. All right, but it's just another thing. So because this one's negative on the top, it kind of tells us D has to be the right answer. And I think on the actual test, I've changed the AP answers to match more with our formula, so they'll have the absolute value. So it'll be a little bit easier to compare the way we have them memorized to the answers. I take the derivative of the following function, arc cosine of tangent of x. All right, so we just know it's a chain rule because tangent is inside of arc cosine. So the first thing you do is take the derivative of arc cosine, which is up here. All right, -1 over the square root of 1 minus x squared. So -1 over the square root of 1 minus x squared, but the x is whatever's on the inside, so it's tangent squared. Right. Times derivative of the inside, derivative of tangent is secant squared. Right. So it's a chain rule problem with an inverse trig derivative. All right, and this would be your final answer. At 3.5 is all about selecting procedures for calculating derivatives, just making sure you're doing the right thing when you're taking a derivative, because now we have all these options between implicit derivatives, chain rule, product rule, quotient rule, all that stuff. All right, so the first thing is, what would be the kind of first step of taking the, finding the slope of the tangent line means you want to find dy dx. What would be the first step if you're doing this implicit derivative? I know it's implicit differentiation because I have these x's and y's mixed together, which says I take the derivative of this, so the derivative sine inverse, we know is 1 over the square root of 1 minus the inside squared. But I have to multiply that by the derivative of the inside, which is going to be 4x plus 2y. And whenever I take derivative of y, I get dy dx. That's equal to derivative of 2 over x is negative 2 over x squared. Derivative of y squared is 2y dy dx. And the way I got that first part is this is 2x to the negative 1, and then I take the power rule. So now I'm looking at this and comparing it. So I definitely have, all of these have the bottom of this part the same, so that's not really going to help me differentiate the answers. I should have 4x plus 2y dx, dy dx on the top, so that takes away b and a. On the right, I should have negative 2 over x squared plus 2y dy dx. So what is the difference between c and d? Is there a difference? Oh, yeah. So the only difference is that little exponent of 2. It's missing in D, so C is the right answer. Right, so make sure you're really careful when you're looking at, especially when there's that much writing for an answer. Right? Make sure it's exactly what you want it to be. Right, so the answer for that one is C, because it has that exponent of 2. Right. Right, so here we have our function g of x is f of 4x minus f of 2x. We have some values. What is the process of finding g inverse prime of negative 5? All right. All right, well, g inverse of negative 5 is related to 2 from the original. All right, so for the original function, it's when we plug in 2. All right, but that's actually true for all these. So let's see, g inverse of negative 5. Using the inverse function theorem, we do 1 over that other slope. So the ones that are right so far, the ones that have a fraction. So c and d are out because they don't have that fraction to do the bottom. We put the inverse in the derivative, which is g prime of 2. All right, so both of these are right up until this point. So now we need to figure out which one's more right in the second part. And then g prime of 2. For this part, we have to do the chain rule, so it's going to be 4 f prime of 4x. Same thing for the 2 f prime of 2x. All right, so that's going to make A the right answer. All right, so inverse function theorem to give us this part, and it's a chain rule to give us that 4 and that 2. That makes A the right answer. All right, which of the following does not require the use of the chain rule? All right, remember the chain rule is when you have one thing inside of the other. Well, here this is a dead giveaway. There's parentheses, so A is out. You definitely need the chain rule. D is definitely out. You definitely need the chain rule. All right, so which one between B and C? Neither one of them has parentheses. All right, so which one uses the chain rule? Well, the important thing to remember is when you have a y in an implicit equation, it's technically always doing the chain rule. So if I do y cubed, the cube becomes 3y squared. I have to multiply by the derivative of y, which is dy dx. So when I have anything other than just a single y, it's actually a chain rule problem. So that eliminates B because I had to do chain rule. So C is my only option. All right, so B doesn't look like you don't need the chain rule because there's no parentheses. But even y cubed is technically like y raised to the third power. All right, all the other ones are just power rule problems. That's x to the 1/2. That's x to the -3. That's x to the 5th. This one we just want to calculate the derivative, and again, this is we have so much in our heads now about all the different ways to take derivatives. We just want to make sure we do it right. For this derivative, first part we just do the chain or power rule. Second part, we need to remember that 1 over x is x to the -1. You could do the quotient rule because it's 1 divided by x, but it's going to take you longer than just remembering that this is -1 x to the -2. And then x e to the x, the most wrong answer we'll see is that this is just e to the x because the derivative of x is 1. We have x times e to the x, we need to do the product rule. So keep the x, derivative of e to the x is e to the x. Keep the e to the x, derivative of x is 1. All right, so I just rewrite this a little bit nicer. And I get that final answer. All right, so again, this page mostly is all about, all right, you have a lot of these rules now, just make sure you do the right one and do it correctly. And our last learning objective is all about higher order derivatives. So remember, if you want the second derivative, that just means you take the derivative of the derivative. Third, you just do the derivative again, and so on. All right, so this one, which of the following statements is true? All right, this is the fourth derivative, second. All right, so we're probably going to need the fourth and second derivative to see which ones happen. So let's do the first derivative. It's going to be cosine of negative x, but that negative x is going to add an extra negative there, minus sine of x. And then minus 10 goes away. G double prime of x. It's going to be positive sine of x, or sorry, negative x, and that negative x makes another negative there, minus cosine of x. Third derivative, negative sign turns into negative cosine, but this negative will put an extra negative there, plus sine of x. And the fourth derivative, cosine is going to turn into negative sine, but again, the chain rule will have an extra negative pop out, we can do a positive, plus cosine of x. All right, so now which one of these is going to be true? If I take the original and I add 10, that'll cancel out, and I get sine of negative x plus cosine of x. That's actually the same thing as what we just got. So that one's true. B would be, is this equal to that squared? No, it'd have to FOIL that out and give me a bunch of weird stuff. All right, so B is out. C, is the second derivative minus 10? So if I put a minus 10 here, is that equal to the original? No, because I have an extra minus sign there, and an extra minus sign there. All right, so that one's not right. And this one is just the second derivative. Is it equal to that? No, again, because of the minus signs. All right, so that's out. All right, so the right one is A, as we knew, because it was the first one we saw. This one's just asking us to find the second derivative. So the first derivative, exponential comes first. Keep that the same. And we multiply by the derivative of the top derivative. 2 sine of x is 2 cosine of x. Now take that's the first derivative. Take the second derivative. Now I have multiplication, so I have to do the product rule. I'm going to keep the exponential, multiply that by the derivative of the second part, so that's going to be negative 2 sine of x. Then I keep the second part, multiply by the derivative of the first part, so the exponential stays the same, and multiply by the derivative of that. All right, so now I need to figure out how do all these compare. So first of all, this e to the 2 sine of x is in both of these, so I can pull it out, which is going to put it there. And actually, they also have a 2, so I can bring out the 2 as well. All right, so these ones are also still right. And what's left over when I get rid of the e to the 2 sine x and the 2? I have a negative sine, and I have a 2 cosine squared. All right, so which one is that? That's D. Oops. All right, so again, just comparing what you have to what's left over. And sometimes it's not clear of how you want to simplify, but you want to kind of see, I had this I could factor out, and I left behind the exact things that was in the parentheses there. All right, so just do the problem, and then compare your answer to what's there. This one is purposely confusing on the AP's part, but that's why we're putting on the test, so make sure you see it at least once. All right, this is f of x. Looking for the instantaneous rate of change of f prime. All right, so instantaneous rate of change we know is the derivatives. We're going to take the derivative of this. All right, this is negative 32, x to the negative 1 is going to be positive 32, x to the negative 2, plus 3x squared. Right. And you would think, okay, well, instantaneous rate of change is the derivative, so I'm just going to plug in 2. Right. But the derivative is the instantaneous rate of change of f. All right, that's the derivative, but we don't find the instantaneous rate of f prime. So this means we have to take another derivative because we don't find the change of that function. So we need its derivative. So that's going to be negative 64, x to the negative 3, plus 6x. And now I plug in 2. So I plug in 2, negative 64 over 2, 4, 8. Negative 8 plus 12, which is 4. All right, so this one is one of those ones made by the College Board that's purposely kind of confusing because you see instantaneous rate of change, you automatically think, oh, I got to take the derivative, and that's true. But you actually have to take the derivative twice because you're trying to find the instantaneous rate of change of the derivative. So you have to do the derivative of the derivative, which we know is the second derivative. Now this one, just finding the third derivative. So count all the tick marks. We need to find the third derivative. So we just go through 4x cubed plus 3 minus e to the x plus cosine of x. Do it again. 12x squared. 3 goes away. E to the x stays. Derivative of cosine is negative sine. And the last one, just the third one, 24x minus e to the x doesn't change. Negative sine turns into negative cosine. Right, so that one's pretty straightforward. Just going down, making sure you take the derivative of each piece each time. All right, so that's the entire practice test now. All right, some pretty difficult problems in terms of the way they're worded. All right, also some ones that are a lot of work for a single multiple choice question. All right, but these are the types of problems that you're going to see on the AP exam. All right, so I'd rather you see them now, kind of struggle and get through them, all right, rather than having to do that all at once on the AP exam later. All right, so look through the practice test again and make sure you kind of understand how to do each problem and let me know if you have any questions.